today we're going to go, that's the sound as well, nice. So today we're going to go from this empty project in IntelliJ that you can see on the screen into something that's running in production and an entire build pipeline that takes us all the way there. So whenever we push new changes, it deploys into production. So in the next 40 minutes, that's what we're going to do, create that entire pipeline using Quarkus Native, Google Cloud, and some other tools. So B1, everything's going to be done live. Hopefully it works. It did last time. So my name is Opheim. I work as a consultant in a Norwegian consultancy company called Kompetas. We just opened an office here in Malmö, so it's extra fun to be here this year. So thank you all for coming. So without further ado, let's get started. And I'm going to get started by downloading Quarkus Starter. So Quarkus has its own starter kit, so to say, which we're going to utilize. So I'm going to head over to start coding. Let's do Kotlin today, because I like Kotlin. So in the starter, you can say, I want to use that plugin and that functionality and so on. So it adds it automatically to your POM file, so you don't have to do it yourself. You can do it afterwards if you want to. It's not a big deal, but for Kotlin, it's quite a few steps in the POM file that you have to edit. So it's an easier experience to just fix it straight ahead. So we download the zip file. We're extracting a zip file. And now I'm just moving the zip files, or like the Quarkus. We can inspect it first. Or maybe it's better to inspect it. Yeah, so you can see here, or maybe you don't see, it might be small for you in the back, sorry about that. But you can see there are some files here. So let's move that into our IntelliJ project. Like this. Now we should have here, yeah. So now you can see that we got way more files. We got some files here as well. That's a starter kit from Quarkus. So what does that give us? Well, we have a POM file, we have a Docker ignore, so on. We have Kotlin, a starter file. So if you want to do an endpoint, this is like how we do it in the example, which is provided for us. So let's see if that works. Let's do a Maven daemon Quarkus dev. When you do coding with Quarkus locally, you can do Quarkus dev. And we'll see in a minute why that is really cool. Okay, so now we have started. Quarkus starts at localhost 8080. And that's congratulations. Why? So you can see the hello endpoint, the example endpoint we just saw. That's here. It says hello. Okay, but we want our own things, right? We don't want the example thing. So let's get rid of the example code and create our own code. Let's call it, for instance, Øredev or Øredev. Add it to get, fine. Okay, so this is going to be a REST endpoint, right? So we make it at path/Øredev. We want it to be available all the time, so it's application scoped. And we create a function, say hi. That says hi from Øredev. I save it. I head over to the web page. Oops. That was not intended to happen. Oh, of course. And if you want to create a get endpoint, you should add @get to it. Here we are. Hi from Øredev. And that's how much code you need to write in Quarkus to get the get REST endpoint. You can see it's not really much. So under the hood, we're using Jakarta E. We're both CDI with application scoped. We're using JaxRS, or Jakarta REST Service, as it's named now, with the paths, and with a return. Okay, that's fine. We want a little bit more logic, right? So let's create a service. So we want to return which year we're in. Okay. So the service can have a year, which returns an int. Okay. But if we try to do that and reload, we can see that oops, and we add the call to the new method. Okay. Let's do one thing at a time. First, let's inject the service into the resource. Let's call the resource or the resource for us to not be confused. And we can say hi from Øredev at year service.year, okay, which is not working, right? Because we haven't defined the year property. So let's do that. we want the year to be injectable, so we can override it in our environment variables, because year might vary, So let's say you had the environment property year. And we can say that if it's not a we can add the default value. So if year is not specified, we say, let's say we're in year 2048. Okay. Oh, of course. I keep forgetting the annotations today. So the service needs to be injectable as well. Okay. Produce. Okay, we can add something that says what it produces. Okay. So it produces media type dot text plain. Okay. What is it I didn't get today? This was working early today, of course. Okay, what happens if we do like this? Something is blown up, okay? Let's do a compile just for the sake of it. This is why live coding is fun, right? Okay, consume star produces text. Okay. Does not really make sense to me, but okay. Let's try it like... Okay, no one. Let's do a clean. Okay, yeah, okay. So something was screwed up in somewhere. Hopefully we get it now. Yeah, okay. I don't know why that happened, but sometimes you just need to clean up a Maven. Okay, so now we inject this, but we're not really inject it because we use default value. So in Quarkus you can specify environment variables during application properties. This is application YAML in Spring, or different file names in different runtimes. So let's say the year is 4096 because we like round years, right? And when I reload it, you can see it's at year 4096. And what I haven't mentioned, but just done so far, is like I do code changes, I save my code, and then I refresh the web page. So Quarkus under the hood recompiles what it needs to recompile whenever I do a new invocation, without me having to start and stop anything. So it's a really smooth developer experience on that part. So let's head back to the Quarkus starter page. We made an application, so thanks to us, but we can also see that I have the dev UI, which has lots of different features. But what I want now is I want health, because we're going to be running this inside Kubernetes, right? So let's head to /health. Oh, there is no /health, because we did not add, we don't have anything, we did not provide liveness probe, readiness probe ourselves, and we did not tell Quarkus that we need it. But luckily we can add it. So in the POM file we had a dependency, so everything that like provided with Quarkus is inside io.quarkus. And it's called, okay, what should that be called? I think I have autocomplete in this one. Yeah. Okay, so the autocomplete is quite nice. It says Quarkus small y health. So health is part of microprofile, and in Quarkus everything that is in microprofile is provided by through small y. So it's like small y metrics, so on, and small y different, so on. So now we can see, now we have a health check. And you can see that even though I did changes in POM file and reloaded, it just recompiled that as well. So you can see under the hood that it just restarted. Not that much under the hood, but like, yeah, you can see here, Quarkus just restarted when I saved and reloaded the page, which is a really nice dev experience. So that's just like a brief Quarkus show-off intro. No, but we need some code, right? Okay, so we've done this. Okay, so Quarkus also comes with a couple of Docker files. So you can see that we have a Dockerfile for JVM, a Dockerfile for native. And but also you have legacy jar and native micro, so like variations over the two modes you can run Quarkus in. Because Quarkus can be run as a JVM application, like regular JVM, but it can also be run in native mode. Is anyone familiar with native mode, like Graal VM, Spring Native, Micronaut Native? Some of you are nodding. Nice. Cool, because it's kind of the same thing, all of those. It's like Graal VM is used under the hood, both here and in Spring Native and Micronaut Native and so on. And what it does is it takes all your code, all the necessary part of the Java SDK, makes it a binary executable, and then you can run that binary executable directly. And that is that is a bigger operation, so that when you compile or like create the Docker image, that takes longer time and demands more resources. But whenever you start up the application, it starts really, really fast. So it's a trade-off between build time and run time. So, but that's what we're going to go through today. Is like we want to be able to commit our code, do a git push, and then we want something to build and the application to be deployed somewhere, right? So we need to prepare our build files for that. And unfortunately, the Docker files that are provided with Quarkus kind of like demand you to already have built your application locally or in some other place. But what we want to do is like we want to build our application inside the Docker, inside the multi-stage Docker build. So we build our application to a native, and then we run that one. And that's what we're going to do now. So luckily, Quarkus has quite good documentations on some things, on many things, to be fair. So if you head into the web page and like search for native, you can find a long guide on like how to build for Docker native executable. I want a multi-stage build. Is it big enough for you in the back, or should we enhance it a bit more? Okay. It looks good. Okay, thanks. So we want to use a multi-stage build. And we can just copy the sample Docker file because it's like a really good starting point, and take that one into our Docker file, which we can add that one to the top level. Say a Docker file here. Oops, right indent. So now we can see it's a two-step build, right? So first we build the image as it says here, using JDK 21. Because why not? So we add the Maven wrapper that's provided with the Quarkus starter as well. So you don't need to you don't need the base image with Maven installed. You don't need to install Maven yourself or anything like that. You just take the one that's provided with Quarkus. You add the POM file. You download everything, because you typically change your code more often than you change your dependencies, right? So it makes sense to cache the dependencies in the Docker layer. And then you package it into native. So this is like if you do Maven D package or Maven package, then you package it into jar file, which is fine. But if you add this property, you can do it in native mode. Once that is done, you start with another base image, a really small one. They named it Quarkus micro image. So it's intended to run exactly that. Exactly that native binary that you just created in the previous step. So it says using Quarkus, blah, blah, blah. Okay, so this is good. Last time I did this one, I got some issues with the package, or like the go offline staff with permissions, because here we switched to user Quarkus, and we used the work/code. Then I got some issues that the user Quarkus does not have permissions to access the work/code. So we removed that line. Or maybe we should say, just for the sake of it, say user root, which is not cool. But like this is the first step in the multi-stage build. It's not that important if you build your application as root. You don't run it as root anyway. Or what you can do to do it even more proper. Maybe we should do that. I won't try to remember it, so I just copy it from the ch own syntax. I never used it, gotten friends with it myself. So let's copy it. So just to make sure that everything works, we, as the root user, we make the Quarkus user have full access to the code folder. so that we know that it works. And then we just, apart from that, the starter file is more than good enough for our needs. Okay, so now we have the Dockerfile, which creates a native binary for us. That's it. That's a nice start. Okay, so we can do it. Yeah. Okay, so let's try to move from our computer into the cloud. So let's start by doing a commit, which I should have done a long time ago. Like in my user flow, I would have done that, but yeah, better late than never, right? So let's do a commit. We like commit everything we've done so far. We could have deleted lots of the files here, right? Because we don't need them, like the sample Docker files and so on. But it's not an issue for now. Okay, and let's push it because we're paranoid. So now let's head over to Google Cloud. So today we're using Google Cloud. You could do pretty much the same things in Azure or AWS or whatever floats your boat. But I'm most familiar with Google Cloud, so let's head there. So in Google Cloud, you build your applications through Google Cloud Build. And what you typically do is you create a trigger. That means whenever something happens, do something. So, okay, let's do Øredev. Okay, so let's see, whenever I push to a branch in the repo, and that repo can be, for instance, Øredev, the one we just created. So whenever we push to that branch, something should happen, and that is specified. You can either specify it through the Dockerfile or to build packs, which I haven't used that much, but you can also do cloud build configuration file, which is a YAML file. It's pretty close to, if you're using GitHub Actions, the workflows there, or Jenkins file, or all those configuration files are pretty much the same, just a small syntax change. You can try it out, but like if you want, what I want to do is like I want to build the application, and once the building is finished, I want it to be deployed to Cloud Run. And to do that, you need to configure something outside the Dockerfile. So that's where the Cloud Build YAML kicks in. And if you want to do this in production, you like want to do a proper service account setup and so on. But that's a different talk. Time flies. But yeah, don't use the default. For anyone who went to Jesper's talk this morning, I guess you got to mean don't use the service account, default service account. Okay, so I said we use a cloud build YAML file. Okay, what is a cloud build YAML file? Let's create it in the root of the repo. Cloud build YAML. Okay, so here I've cheated a little bit because I don't remember the syntax by hand. You can find it in the Google Cloud documentation. It's quite, okay, let's do it properly. So it's quite like basic setup. Says, okay, whenever you're done, run the deploy of the image. And use Europe North because we are in Europe North, right? And allow unauthenticated request because we want our application to be available to the entire internet. And yeah, timeout 1200 seconds, that's like 20 minutes. Should be more than enough for building a simple application. Don't worry, it doesn't take that long. But so we could go with this, it's perfectly fine. But we miss a few of the features with Docker by doing just this, because Google Cloud Build does not by default have a layered caching mechanism. It's not like activated by default. So if you're doing this, you're missing all the features of like caching dependencies and so on that we just talked about. So what you can do is using Kaniko. And Kaniko is a build cache. It's very well featured in Google Cloud Build. So like you add Kaniko executor and say you want to do caching, and that's pretty much all you do. This is also from the standard documentation, so nothing that special, but it's worth adding. So if you add this one first, then Google Cloud will use Docker layers the same way as we do as Docker does on our native computer, or Podman or Cryo or whatever. So okay, and that's that should probably work. But that depends on the size of your application. If you have a really small application like we have now, this will work pretty fine. But if you have like a big, or yeah, if let's say it that way, if you have some code base that you probably use in production, it's supposed to be much bigger than this. So you might need more power to actually be able to build it. So what you can do on Google Cloud is you can say, I want it to be built on a heavier machine. That's the options thing here. So we'll add that just to be sure that we don't time out today. So this is more expensive, and it's not that available. So sometimes you need to wait for a few seconds before your build starts so that the heavy machine is available for you. The good thing about this one is like, how do you know if you need it? Well, the answer to that is pretty simple. If your build times out or says out of memory, you need it. So start without, and if it fails, then add it. So this is the entire set of instructions we gave to Google Cloud on how to build our application and how to deploy it. So let's do added cloud build YAML. Okay, this is not a good commit message, but this is something. And we remember that a few minutes ago we set up the build pipeline in Google Cloud so that whenever we do a push to the branch, a new build should start. That means that when I now do a git push, we expect the build to be starting, which you can see probably in the dashboard. No builds, okay. Which is the history say. Okay, so here you can see the status. That the icon means that it's waiting for an available builder, a building node, which I just said that there aren't that many of them with that much power. So the longest I've been waiting for this is like 30 seconds. It feels long, like building time always feels long, but it's actually usually pretty fast. So while we are waiting for that, let's jump back here in a couple of minutes. I just want to be clear to you. And I have done some preparations, but nothing that's really interesting. I've installed Graal VM on my computer. Okay, I created the GitHub repo where we push the code. I created a project in Google Cloud. I enabled building on it. This is probably the step that might take the longest time to start here, getting acceptance and someone to pay for it. I enabled the Google Cloud APIs for build and run, because you need it. In Google Cloud, you need to enable the APIs that you want to use. I give the build service account the Cloud Run admin and Cloud Run service agent role. That is so that Google Cloud Build can push the image to Google Cloud Run and say, run this image. And I made a connection between the GitHub repo and the GCP project. That's all there is to it. The rest we're doing now. Okay, oops. This is not a good sign. No source. Okay. Oops, I forgot about this part, but I know what it is. So I said that the Dockerfile, they weren't tailored for our needs, right? That also means that the Docker ignore file is not tailored for our needs. Because did anyone see this while I did it first time? Okay, nice. Okay, because here we do we copy the POM file, the Maven wrapper thing, and the source code into the Dockerfile, into the Docker image. But in our Docker ignores file, we said that ignore anything that's not inside the target folder. So we need the source file, we need the POM XML file, we need the Maven.maven, and we need the Maven wrapper. These are the files that we're copying into the Docker image. So let's try again. Smart to remember to update everything. And then we try again. This is the best part about doing live coding on stage, by the way, when something fails and you know what it is. So hopefully we'll have a new build starting pretty soon. And we still have 50 minutes left, so that's lots of time. I think that this build typically takes 2 or 3 minutes for the first time. So it can fail like four more times without being an issue. But fingers crossed. Okay, so let's wait a little more for. Okay, is there anything more we should say here? Okay, let's. Yeah, so you probably want to do some testing, and Quarkus provides you with some examples of that as well, like given when done on the endpoints. So this is the way to do it. You can just go ahead and copy. Or you can just use regular JUnit or Mock-K or whatever framework you want to use. It's plain Kotlin after all. Fail again. Oops. No source file specified. Okay, what does that mean? Okay, let's start by checking if it works locally then. Failed to optimize. It fails pretty early. Okay, let's do a docker build .-t Øredev. Oh, we're now with downloading here. Okay. Failed to complete cache keys, source not found. What? This is strange. Okay, how far do we get? We get to copy source into. Cache key / source not found. Okay. You know what? Let's cheat a little bit because I've done this before and then it worked. Okay. Okay, so that was the user trick thing. That's the difference. Okay, let's see if that makes a big difference then. What is this? Oh, do I need the source slash, perhaps? Is that something? Okay, let's also do a quick cheat here. Okay, so remember your syntax, folks. You need to add this one, or else it's not copied in. Okay, oops. Well, you learn as you live, you learn as you go. Okay, so maybe I should go back to the Dockerfile we had. Maybe that works now. Yeah, looks like. Okay, so let's try again and push it. Syntax is important. So that means that the docker ignore file, like the exclamation mark means do not ignore this file. Now we'll learn that. So hopefully that helps us. Okay, so I think I'm right now just waiting for this. So do we have any questions? Good, let's see what happens here. Oh, by the way, does anyone, I hear that I've spoken about Google Cloud Run without explaining it. Does anyone know what Google Cloud Run is? Okay, you are a lucky one. Okay, to the rest of you, I'm sorry. Google Cloud Run is Google Cloud's serverless running ability. So it says like, compared to Amazon Lambda, for instance, it runs your container, and if it's not used within a while, it scales down to 0. And that means that if, oh, now it's building. Okay, so we're getting further. That's a good sign. So that means that if you have like a very let's say, varying number of users, say you have a user every now and then, or like you have users on Tuesday afternoon, for instance, then with serverless and Cloud Run, it means that whenever it's not run, like whenever you don't have any users, the application is not running. That means that your cloud bill gets slower, so you don't pay for more than when it's actually used. And that means that it's suitable for projects where you, say side projects when you don't have the money to pay for application running all the time, or all of these things as well. But in order to make that a success, you need to make it fast enough so that if a user comes in, your application has stopped, and you need to start your application. It needs to start fast enough so that the user does not get impatient and go anywhere else. That means that you have a few seconds on your test failures. Okay, so I deleted the endpoint, but I did not delete the test. Of course, that fails. Let's just do a quick hack and delete the tests. Please don't do this in production. We don't need tests. Okay, that's the biggest lie of today, but so be it. And now so you can see we got quite a step faster. So now we can see the caching mechanism in use again, so that now you can see on this build that failed, we do a lot of downloading from Maven Central. That should not be necessary on the new build starting now, because we already downloaded the dependencies and cached that layer into Kaniko. So we are waiting. So where we're going to end up is in Cloud Run. And this is what the Google Cloud Run console looks like. It's not that interesting when you don't have anything running. But in a couple of minutes, inshallah, we can find our application here. Then we'll have a more close look at it. Now we're trying again. No cached layer found for. So yeah, you can see using cached version of this. So this is the steps that downloaded all the dependencies. Now we don't need to do that, so we just start at the layer where we failed the last time. This might take a couple of minutes, but that's not an issue. Okay. So the native thing does some more things. Okay, yeah. But here we are. Now it's building. Hopefully that's enough. Yeah, great.
What's the biggest advantage of Quarkus versus Spring Boot, in your opinion?
Okay, so I would say the biggest thing is that with Spring Boot, you do things the Spring Boot way. The answer is like both the biggest advantage and say disadvantage. While with Quarkus, it's based on Jakarta EE and microprofile. So that means that if you go Quarkus and you're disappointed with Quarkus, you can switch to OpenLiberty from IBM or Helidon from Oracle or any other application server implementing Jakarta EE without changing your Java Kotlin code at all. You just change the config and so on. So that you are more flexible on what you want to run on. And like, of course, but also the fact that if you know Java EE or Jakarta EE from before, you can use that directly. Other than that, Spring is also great. So it's like, great. What should I say? They challenge each other and improve each other. So like, you can see, it wasn't that many months between Quarkus Native and Spring Boot Native, because like, the developers of the application frameworks speak together and like discuss ideas together and so on. So I think like there's this concept of co-opetition, where like cooperation and competition at the same time. So nice. So deploying container, done. Okay, that's a good sign, right? So now we can see here on Google Cloud. Yeah, so that was 2.5 minutes. And that's 2.5 minutes, but like the simplest, smallest demo application we could think of. So you can see that there is something. There is a trade-off here between building time and running time. But what we can see in just a second. Okay, so here you can see. Okay, so deployed it. So now we can see how fast it starts. Let's see, Øredev. Hi from Øredev. And that's like the biggest feature with Quarkus Native, right? It's a fast, or anything that's based on Graal VM. It starts really fast. You can see it started in 0.169 seconds. Whereas if you were running the jar mode, it would be like 3, 4 maybe. So the difference, like for me as a user, is like when I do Quarkus Native, I don't have to wait, or like the waiting time is so short that I don't get annoyed. In that sense. And that means that here we are. Oops. Let's copy the URL. And I'm not sure if we're exposing the health service. Yes, we are. OK. So like you might want to do some filtering like on what you expose and so on. But for now, we expose the application. Oops. Yeah, you just made a Quarkus application. So this is like not good information to have running on the internet. But what you typically do, right, is you create this application as we did. We use that as a backend for a front end. You don't expose the backend to the entire internet as we did, but you can do it. It's not, but you need to think of more security things. But typically, we would expose this application only internally on Google Cloud, so it's available to the front end from there. And I think that was it. I think I'm through it. Do you have any more questions? Yeah, nice.
Is there any limitation what you can do from your Java code when you're using native mode?
Yes.
Or do you use Kotlin?
Yeah, it's the same thing. Yeah, there are some limitations. So like what I run into is frameworks and libraries that don't support native mode. There are some things like you can't have random stuff. The code needs to be deterministic. So because it's compiled into native binary at build time, like not something that kind of things can't be done. Random doesn't work. That's a limitation. Yeah, reflection is disabled by default, but you can do it. It's doable. But you have to activate it manually. But it's possible. I'm not sure if I would recommend it, but you can do it. So that's a trade-off. Okay, so now we have gone all the way from nothing to production in exactly 37 minutes. Okay. Thank you all, everyone.